So unbalanced voltage is another problem that can arise. This time, unbalanced voltage, remember, it is something external, okay, that is caused by the power quality that is fed into the electric motor. So remember that the an unbalance in the voltage input to the electric motor of 1% can result to 10% current unbalance. Okay, so that 10% current unbalance, you will see that it will affect the electric motor. So if you look at this motor, you see the pattern that one is untouched, one is slightly overheated, and the other one is burnt. So you see that pattern around the electric motor. That clearly tells you that the voltage is unbalanced. Are we getting it? So now, to once you notice something like this, is to look at the power input to see that the phases are always balanced. Okay, so once you have unbalanced voltage or phases, the electric motor should shut down. Of course, you want to set a tolerable limit. Okay, a limit of about between 3 and 5%. Are we getting it? Remember, we said 1% unbalance can result to 6 to 10 times 6 to 10 times current unbalance. So we want to be very careful in setting it. So in some sensitive situation, we want to even set it less than that 1%. Okay, 0.5%. So the overload too, that is the load that is attached to the electric motor itself, if it is more than the what the electric motor is designed for, it can result to this. Remember, it's a sustained overload, and the overload current is the same thing on all of the phases. Are we getting it? That is why you see this kind of uniform burning. That is, the load on it is too much. Okay, so we want to identify and then try to see what caused the overload, because some fault conditions too can result to overload. Fault condition associated with, like in this case now, you see we have the gearbox and the pump itself. So the fault condition could be in the pump itself, maybe faulty bearing or faulty coupling to the gearbox, or faulty coupling between the gearbox and the electric motor. All of this can increase the loading on the electric motor itself. So we want to determine what actually caused the overload and rectify it. If the actual load is more than the capacity of the electric motor, of course, we want to increase the size or reduce the load on the electric motor. Okay. So on single phase electric motor too, you'll see that this pattern of burning, we have two sets of coil, the running winding, which is the main winding, and the starting winding, which is the auxiliary winding. So during normal operations, the current normally flows through the main winding. Okay, so once you see an overload, once there is overload on the, so you see that it will affect this main winding mostly, and that is what you are seeing here. Okay, so that clearly shows that the single phase winding is overloaded. Then locked rotor current too, which is almost similar to that overload. Okay, there's something seizing the rotor from turning, maybe faulty bearing, could be overload or stop load. Are we getting it? Anything that can prevent the, as it's starting, instead of turning, it to be humming, that will result to lock rotor current flowing through the windings. And remember, lock rotor current, once sustained for more than some fractions of second, it will affect the insulating capacity, that is insulating materials of the electric motor and the winding, and that is what will result to this kind of burnt, as you can see on your screen. So this is another example of a lock rotor lock rotor damage, okay, on the electric motor winding. We talked earlier of a voltage surge, okay. Voltage surge, we know, is like putting an over pressurizing like a hose now. When you over pressurize it, what will happen? It will burst at the weakest point on that hose. So it is too. Once you have that surge that comes into the winding will definitely fail at the weakest point, which could be any of the connection point, or where we already have a failing insulation in the electric motor. So you see that energy burst, okay. That tells you that what actually causes is a surge, okay. So we want to put a surge protector on the line supplying the electric motor, such that once there is the surge in the system, you can clip it or trip the electric motor